this is Sida. I'm Sida Shen, and I am a product marketing manager here with Seta Data. And so in today's 30-minute session, we're gonna go over what is user-facing analytics and how to build an user-facing analytics application that scales. Okay, so first let's go over the agenda. So first I'll spend some time going over what is real-time, what is user-facing analytics, what it is, and how is it used, and probably cite probably three of our StarRocks users and their actual use case, right? And then we'll delve deep into user-facing analytics. We're going to talk about is problems, challenges, considerations, and solutions, right? And we're going to go take a look at high concurrency, how do we solve that, and real-time mutable data, as well as how we're able to serve tens of thousands of tenants and with efficient resource isolation between them, right? Okay, let's go into user-facing analytics. So first, what it is basically a process that provide real-time data insights to your end users. And that end user doesn't have to have much of technical skill. So you can get the data and insights with basically no engineering, no coding effort, right? And this really helps your users make those data-driven decisions and just do better. And if they're using your platform, it can definitely increase their engagement and retention, right? Because they're being more successful, right? And here are some of the general use cases, and I'm not gonna go deep into this one. So it's basically you have those internal use cases, right? You're in a corporation, and you can build dashboards and reports, right? So you can get, let's say, a performance report of an employee, right? Aggregated result with a simple click of a button, right? Or you can have those, external use cases like, personalized recommendation, right? And get aggregated result like fast, right? With a lot of users. And then we're gonna go into the industries, and this probably dive a little deeper with a few examples, right? First, I want to talk about logistic management. I have the privilege to work with a pretty big international logistic firm, and they have hundreds of thousands of delivery drivers and hundreds of distribution centers across the globe, right? And they basically took StarRocks and built this kind of centralized analytics platform that's used for a lot of things like route planning, route optimization, internal analytics. Like the different teams use it to do like ad hoc query, but that's probably not user facing. But build those like intuitive dashboards and reports with a click of a button, right? So just imagine you're a delivery driver at that company. You would have a phone, right? And use that phone to direct, where you should go next for your next delivery, and also with the optimal route, right? And the second industry or case I want to talk about is gaming, and it's also a huge gaming company I've been working with for a long time, and they have hundreds of titles, and they have a bunch of studios too making those games, and each studio has like different teams. So it's a huge company, and they make a lot of stuff. And so they had a problem before, right? So because their data were all like scattered around, and each studio, each team were making their own kind of metric to evaluate how well their games are doing, right? And so they wanted a centralized, like a platform that can standardize everything, right? So they took StarRocks and built this analytical platform. So, as a employee or as analyst in this company, any game you can log into that platform, and with a few click of button, you can know, how well game is doing in real time. So you can adjust the strategy and as well as like run promotions or events, in those games to boost your revenue. Right? And this is important. And the first two are probably more would say internal facing, and the third is more external facing, right? And this is a social media platform that has, not sure about now, but I think 2 to 300 million monthly active users. And the one of the big source of the revenue is a lot of advertisers run ads on their platform, right? And so they provided a service, ads analytic service, so the advertisers can in real time log into their console and see how their ads are doing and uh, adjust strategy based on that, right? It has to be real time because every second counts, right? Every second you're running ads, you're spending money, right? So you always want to get that fast result for a lot of advertisers at the same time, right? Actually, all of these three cases are on the Set Data blog, and the first one is JD.com, second one is Tencent, the third one is Red, and you can go search up and read those blogs, right? And then we're gonna go into the details of user-facing analytics. Basically, talk about the challenges, right? So the first one is high concurrency queries, right? With user-facing analytics, we want low latency query with thousands of QPS, right? Just imagine that logistic company, right? You're a delivery driver. It's 100 degrees outside. You pull out your phone and you have to wait 5 seconds for for it to tell you where to go next. That's not ideal, right? And not only that, right? You're probably not the only delivery driver out there that's doing this. Probably hundreds of thousands of delivery driver using the same platform, trying to query the same data. Platform trying to query the same data, right? So you want very high concurrency, right? And for high concurrency workload here, I kind of summarize that into two kinds of different workloads. First is your IO bound workload. These are, you're bounded by either your disk, right? Your disk means that you're scanning a lot of data, right? Or it's bounded, probably by network IO, is which often happens when your return set is huge, right? You return like 50 million rows of data, and that can cause some trouble, right? And these are all like less complex queries, such as point queries. So these are like selects with a bunch of wheres after it, right? And generally the QPS is a bit higher on the higher end, right? And typically requires latency in the low, like tens of milliseconds, right? Like 50 milliseconds on like often a mass amount of data. I've seen some customers or some StarRocks users in the crypto space, right? They're trying to a lot of transactions, and they want to pinpoint a few transactions and return them. And with very high QPS, a lot of billions of rows of data, right? So this is more of your like IO bound workload. And for CPU bound workload, these are all like CPU becoming the bottleneck. So what is that? It's your queries are more complex, and they're more like OLAP style queries with a bunch of joins and aggregations, right? And because the queries are intense, and they're sometimes for reports. A lot of them are for like dashboards and reports, and so you want the latency to be at least interactive, right? So here I want to say interactive is maybe the query returns during the attention span of a normal human being, like maybe like a second, or a sub-second, or in the low second, right? And normally for these kind of workload, the QPS is not that high, right? And so here we talk about some solutions, right? So first, for those IO bound workloads, so basically two things we need to do. The first is to scan the least amount of data possible, and to reduce to have the least number of disk access that we do, right? And so this is kind of like the general idea. And how to do this works in StarRocks, but also works in other solutions too, right? And first one is bucketing, right? This is a strength of StarRocks. We can, I would say this as a fine grained control over how your data is distributed in your nodes, right? And if you have you want to filter on like ID row, right? And you can put that ID row as a bucket key, And so, because ID is pretty high cardinality, right? So probably going to fit in one small bucket, right? And so every time during a query, you just directly go to that bucket, scan that one bucket, and that's all it needs to do. So do bucket pruning, and it really accelerates your query, right? And also, you want to pick a high cardinality column to avoid data skew, right? And this is good. And second, you can use those secondary indexes, right? First, you can set an order key, so a lookup is runs in log n. It's much faster, right? And you can also use StarRocks provides bitmap and Bloom filter index, and to even accelerate the point lookups even more, right? And we have customers that use bitmap index on the huge billions of rows and get like tens of milliseconds of response time for a single query, right? And yeah, and all of these indexes are cached in memory. So if you use them, you have like moderate amount of memory. You can avoid a lot of disk access too, right? And the third one I want to say is more on the hardware. So I/O is probably one of the easiest thing to scale, especially for drives, right? So you want to configure like multiple high performance SSD drives if you're doing like high concurrency point lookups, and right, and StarRocks actually support that. The more SSD you put on it, the faster it's gonna go at linear scale. And also, you want to have good network, right? Good network in terms of latency, and in terms of throughput if your return set is huge, right? And then let's go to more kind of like CPU bound workload. And the CPU is put at work. So what we want to do is to actually minimize the amount of computation a CPU has to do during the query execution, right? There are basically two ways summarized to do this. First is through pre-computation. So you just anticipate what is gonna be queried by the user, right? And you prepare that result beforehand, right? Pre-computation, pre-aggregation, denormalization, right? Or you can use the previous result from other users or from the same user, right? And you reuse the result or the partial result to take load off your CPU, right? First, you need a kind of like an intelligent hierarchical like caching system, right? So here, two kind of cache. First kind of is like a final result cache, right? So this is the result, the final result is cached. So so the query and the scan data needs to be identical, right? And this is very useful for for folks like me. When I use the application, it's a button I just like to click on it. I don't know why. And yeah, and this definitely does well for that. And but it's just a final result cache, right? A lot of users build this into their application layer, and but it doesn't really solve the problem of like for a dashboard, right? The underlying data is always changing and the queries are not identical at all, and they're similar, follow a kind of like a structure but not really identical, right? And StarRocks has this query cache feature. Stores the intermediate result cache, right, after the first aggregation, right? First local aggregation, right? So you can accelerate aggregations and aggregated queries and also multi-table aggregated queries. So for those local joins, can be accelerated as well, right? And for this, your data doesn't need to be identical, right? It can include like more partitions, and we can do this reuse like part of the result from the old partition and new partition union together, this kind of thing. Or if your query is not like actually identical, as long as they are semantically equivalent, works too, right? Or else you have append-only data, it works too, right? And the two cache doesn't, in my opinion, doesn't replace each other, right? It works for different scenarios, right? And both of them are extremely useful, right, for user-facing analytics. And then is pre-computation, right? And StarRocks has, or Cellular Data has, very good join capabilities, right? We do on-the-fly join, probably the fastest in our track now, right? But for a lot of the high concurrency scenario, you still need to do some denormalization, right? Join is still a expensive operation, right? And instead of doing that on an upstream, like a stream processing tool, doing a stateful operation, do a join in a stream fashion and then insert into a flat table. What we offer is what StarRocks offer is a partial update. So you can have, let's say, a table with 200 columns or 100 columns, right? And you can have a stream that updates like 50, and the other stream updates the other 50, right? So you don't have to maintain an upstream, like stateful stream computing tool to do this, right? You can do it directly in StarRocks, and this is offered through the primary key table, right, with the primary key index, right? And second, do pre-aggregation, real-time incremental pre-aggregation through StarRocks single table or synchronous materialized views and aggregated table, right? And those are all like streaming, not streaming, but incrementally updated. So the amount of computation to update the aggregate table and MVs are not really dependent on the historical data set. It's only dependent on the new ones, right? On the new ones there, right? You can take a look at that. I talk about this extensively during my last webinar, and you can check that out too. The 3.0 update. And there's a new feature coming in. It's called a generated column, right? This is basically like a materialized view, but materialized a column, right? So this is especially useful, if you have semi-structured data like JSON, right? You want to do some computation, you can predefine some computation there, or you have some like incredibly complex regular expressions, right? And this can work really well too. This is coming up in the 3.1 release. I think in what day is today? Like in a week or two, right? 3.1 official release is going to be there. If you guys want me to do a 3.1 update, please let us know, right? And we're probably going to do one. Okay, and the next one is fresh mutable data, right? And user-facing analytics definitely demands real time, right? Like let's take that social media platform, the one that does the ads thing, for example, right? If you're a user, you're an advertiser, right? You're looking at the data that's 5 minutes old. That's not good, right? Because every second you're running ads, you're paying money, right? You're losing money or paying money, right? If it's not working well, I want to know the result as soon as possible, right? This is why fresh is important. And mutable data is important too, right? Because a lot of things like, a transaction, like an order status, right? That thing changes. If you can't really, like support updatable or mutable data, you need to keep a change log of everything and do the aggregation or aggregate, find the latest result sometime. It's a lot of, it's not good, right? So mutable data is very important, and existing solutions really relies on merge on read, right? It means that we're like our analytical database, we use columnar store. So the data is stored in a columnar fashion in large chunks, right? Updating that in real time is not that simple because update are, a lot of them are role based, right? And existing solutions based on merge on read means that every time you write into a different version, and there's a compaction job in the backend that does all, merge them together, right? And this can have a huge, the compaction in the backend can have a huge impact on query performance. Not really only making it slow, but it makes it unstable, right? It's not really good for production environment. And if you set it for 2 minutes, it's okay, but in the low seconds, it's probably not going to work so well if your volume is large, right? And what StarRocks can offer is a delete and insert mechanism through the primary key index, right? And this primary key index hash the primary key, and it's stored, and you know exactly where that primary key is stored on disk. So all of the uh, update uh, are resolved at the data ingestion, right? So it's more like a merge on write kind of uh, way, right? So there's no like merging different versions in the backend happening. So this can really support real time mutable data uh, freshness, in the low seconds. That's possible to do, and with absolutely no compromise on the query performance, right? And the next one is efficient resource isolation. So let's talk about why do we need resource isolation in user-facing analytics, right? Imagine you have like 1,000 users using, and a lot of them are probably a little more important, or and you want to maintain your business critical operations, right? So they're not interrupted or disturbed by other tasks, right? And you also want all of your users to have a certain user experience, right? So assure that you have a minimum amount of resource ready there, right? So a current approach I see in the industry now is a lot of like physical isolation, right? On the VM level, or on the it's on a virtual machine level, right? It's very effective. I have to say that it's very effective. So it's completely separated. The CPU, RAM, and IO, everything's completely separated, but it's not really that efficient, right? The hardware utilization rate is low because everything's separated, and the cost gets really high because you have to maintain the peak demand of each user group, right? Each user group at all time, right? It needs 20 gigs at some time, so you have to maintain 20 gigs at all time. And it really gets worse when grow to like tens of thousands of tenants. For each tenant you need a separate physical machine to do that, and that's a lot of money, right? A lot of cost. And what StarRocks Accelerated has to offer is a kind of like a novel intra-process resource group, right? This is not on the physical level. This is on like different process, right? And so this enables our StarRocks resource group to support over provisioning CPU resources, right? And it can maintain it can so all of the users are gonna get the minimum amount, but if there is like free uh, resources that are not taken, right, our resource group's roles can take them, right? So it's more efficient. It's gets higher utilization on the CPU, right? And with ours, there's three kinds of kind of like a workload. Yeah, that's you can define, and be very suitable for this, right? So the first type is we call the short query, right? Those are those like time sensitive queries, and with those are with like dedicated resource, so these cannot be over provisioned by other tasks, right? Those are time sensitive, and we want them to run really fast and fail really fast, right? And so if it runs for more than a few, you define the number, and it can be automatically killed because in a lot of use cases probably not useful anymore, right? And we have a query queue too, and query queue is the exact opposite, right? Those are not time sensitive, but they're critical. They have to be finished, right? Those ad hoc queries, right? And you can configure that too. And and we also has the capability of killing big queries, by specifying customized rules, right? And this is a pretty complex technology, and you can go to the StarRocks or Data documentation and search up resource group here, and learn more about it. And this is incredible. I mean, it help a lot of our users, with when they have a bunch of users using their platform, right? And this is all. This is all I have. And let's see if there's any question. Oh, what is a question from Tyler? what is the difference between user-facing analytics and customer-facing analytics? I've seen both. Uh, oh wait, I have to make it public. Okay, but aren't I've seen both, but aren't they just the same? Not really. I mean, different people really uh, categorize them differently. I mean, there's a lot of definitions, but for me personally, at least, I think customer facing is a part of user facing. Have another question from Andrew as wait, what are interactive analytics, right? Interactive analytics in OLAP, I would say, is the query. So the user expects the query to return without him, leaving the seat and do something else. So it's basically those sub-second queries and the queries that returns in a sub-second or in the low seconds. How many concurrent users have I seen? Um, Let me see. Like with the ad, with that social platform example we're talking about before. Let me make it public first. Um, like that. During the stress test, StarRocks was able to do 10,000 concurrent user, but they have in the high hundreds in the production environment with all app style queries. Okay, I think we went through all of the questions, and there's another question. See, how many rows can be joined in under 5 seconds without pre-calculation? This is a difficult question to answer, is because it really depends on how much resource you have underneath, right? And I'll answer this in kind of two parts. So the first part, the raw power, you can go to StarRocks or StarRocks website, and there is performance benchmark where we're pitted against all of the like Trino Presto uh, and Photon, and those tools are really good at multi-table querying, and we're 3 to 5 times faster than that. And another strength of StarRocks is that we're designed to linearly scale, right? So, however number of seconds you want, you can basically horizontally expand the cluster and get more performance out of the cluster almost linearly. We do it better than anybody else on the market in regards to that. And also, we're the most efficient of getting performance out of the same CPU. So yeah, I didn't give a number, but that was a long answer for this. Okay, I think this is it. Thank you. And thank you guys for joining, and thank you for all of the questions. And we'll see you guys in the next one. Oh, that's another question. Sorry. Is Data a commercial version of StarRocks? Yes. Data we have a Data cloud offering that you can see that as the cloud version of StarRocks. Yes. Okay, if that's all, if I have more question, go on Slack and search my name, Sidashen, and always there, and at me. And um, yeah, thank you guys for joining again. Thank you.